Good morning. I hope all is doing well, and it's my pleasure to start the session for today. So, dear authors and invited guests, welcome to our first technical session for today, which is the fourth session for the conference. Good morning, good afternoon, and good evening, based on the time that if your place. It's my great pleasure today to welcome you to the fifth World Conference on Smart Trends in System Security and Sustainability, unfortunately through Zoom, on behalf of for 2021 and the Global Knowledge Research Foundation. We are thankful to everyone to present in this platform to go along with digital conference under these unpredictable and hard circumstances that we are all suffer from. But by scientific efforts, everything will return to the normal, and we will came through the challenges of COVID-19. And so thank you for making this conference happen and making it more more productive. We wish everyone and their families to have safe time, and again, for sure, we will all together pass through the hard circumstances and to return to our normal. We hope that you are enjoying the second day of the conference, and from the beginning, you are welcome to join the other sessions, and we hope that everything would be knowledgeable and interactive sessions that would add on value to every one of you. The first thing of today is to welcome our chair for this session. Actually, the profile is rich, so it's not easy to be summarized within one or two paragraphs, but we will try our best to get most of it. So, most welcome, Professor Chandari. Professor Chandari receives a bachelor degree in CSC in West Bengal University of Technology from India. His master degree in the CSE also from DRMGR University in India as well. He has received a PhD degree in 2016. He has 10 years of experience in teaching as well as in research. Currently, he's working as an associate professor, an associate professor in the Department of CSC at UBES Darha University. Recently, he has received the Global Research Education Award in Excellence in the Best Young Researcher Award in 2018. His area of interest include the human computing, software computing, cloud computing, data mining, and others, which are all the trends in the current age that we are passing through. His lifetime member in IETA, member in IEEE. Also, he's an active member in IET UK and many other technical societies. He's also associated with corporate, and he's technical advisor in many companies, mainly in Indian Engineering Teaching Association in India. So most welcome, Professor, and it's our pleasure to lead the session for today. And quickly, I will start with the authors. But before that, I want to just to stress on some key rules, which are that you have 10 to 12 minutes. I will raise a flag when you have a limited time. I will use my marker just not to interrupt you. Then you have 3 minutes to complete and to hand over the session to the chair for and to the audience for questions and answers. Dear audience, if anyone have any question, just please push it to the chat button. If anyone has technical limitation in the presentation and so on, can share with the presentation with me, and I can help in this. So the first paper would be presented titled as People Number Scanner Made on iPhone for Avoiding Big Crowds. It would be presented by Mr. Sazapu on behalf of the co-authors from Romania. So could you please just share your screen? I will stop it from my side, open your mic, and we are all listening to your presentation. Yeah, thank you. We can see it now. Hi. Could you please just unmute yourself?
Yes.
Okay,
Hello.
perfect.
Sorry.
Hi. Hi. Yeah, no, it's fine.
I would like to present my paper, which is entitled "People Number Scanner Made on iPhone for Avoiding Big Crowds." So shortly, about this paper is that how the idea came. Unfortunately, it came because of these pandemics. So until then, we didn't think about this, but nowadays, because of this bad situation, we need to avoid big crowds, and we needed to do this. Maybe if we pass this hard period, then we we can use this app not for avoid big crowds, but to really want to go there. If, let's say, we have there are more concerts in a place, and we want to go in the place where are more people because maybe the music is better. Hopefully we'll get to that level too. So the content of my paper is I will make a short introduction, and I will present how this people number scanner works. So with the use of location clustering, use of reverse geocoding, the satellite view, map rotating, and conclusion. So as I said previously, the idea of this paper was to avoid big crowds because of these pandemics. So, but of course, we can use it for other in other reasons too. If you want to avoid traffic jams, or we want to go shopping in supermarket really quickly, and we don't want to stay too much in the line when we make the payment. So initially, the first print screen of the app, I took a classic map. In this situation, the implementation was done on iPhone, so iPhone has its own maps, not Google Maps, but it can be implemented also with Google Maps too. And each person who installs the app can share its location, so GPS coordinates. Those were uploaded in on a server, on an SQL server, on a database, and the app reads out all the locations and make clustering. So this is the hardest part that is done. So more locations in the same place are clustered in this blue circle. So we know that in this place there are 5 people. And as if we zoom out the map, then the clusters will be bigger, and we zoom in, it will be smaller circles, smaller cluster of persons in a certain place. The second part was what was implemented. As you see, we zoomed in the map, and the clusters. So the people who weren't clustered, so they are split in different places. And reverse geocoding means that based on the GPS address, we can see the exact location of the person. So not GPS coordinates, but normal addresses. Also, the app has this satellite view function using this button. So pressing on this, we can switch on satellite view and standard view. The button under it is to always zoom to our own location. And on the last screen, we can also rotate the map. So when we start to rotate it, then we will see this compass style button. And in case we don't have standard location, then the compass appears. If we click on the compass, then we shall have the normal rotation, so north to be in the up of the screen. As a conclusion, it was presented this app which can count the number of persons in a certain place. So we use the simple maps app. The I think the hardest part was this implementing this clustering function, which was a little bit challenge, but finally we managed it. As I said, this app can be used for avoid big crowd supermarkets or everywhere, or avoid traffic jam. And of course, to avoid persons or big crowds because of this unpleasant pandemic situation. The app, of course, has a few flaws, so it works better if more persons installs this app. This app was done on iPhone. The hardest part is that the population in the world are somehow splitted. So a few of them have Android phone, the others have iPhone. So further enhancements would be to implement this app in Android too, and use the same database with the people location, and represent the clusters of people, even though the user has iPhone or has an Android phone. As for this, I would like to say that finally also the Android version was implemented, but it's not the aim of this paper, but I say it like this. It was, again, quite a lot of work, because it was totally a different programming environment, so everything needed to be redone by scratch. Only the idea is the same. For acknowledgement, I would like to thank my university for the given support, Politehnic University Timișoara. There are some selected references, and I would like to thank you for your attention.
Roland, it was a nice presentation. Thank you for the same. But I have a few questions. May I?
Yes, of course.
Yeah. Actually, why you have used geocoding?
Reverse geocoding. It was done because if someone, sorry, in this slide, if someone clicks on a location like this, it's not nice to see some GPS coordinates. It's nicer to see a normal address, let's say a street and a number.
Okay. But in your paper, we have not seen any algorithms. Actually, you have used some clustering method, is fine. But how the clustering method is running, and what is the basic method behind it, you have not mentioned. So better if you can mention it properly, so that all the listeners and all the viewers can also understand. And if you are having any point on that, kindly please discuss.
So actually, the clustering method makes let's say a square on a certain place on the map, and counts the number of GPS coordinates in the same place, and writes it in a cluster. So depending on the zooming, it will decide how many GPS coordinates to place in a single cluster.
Okay. And what type of cluster algorithm it is?
It's not a type of algorithm. It's something own. So it's an
okay. Fine, Roland. Thank you. Now after
Okay.
Feroz. Thank you.
Yeah. Thank you for the presentation.
Thank you.
We don't have further questions in the chat box, so we will continue with the next presenter, which is also at your side. You will present your second paper titled as on behalf of your co-authors as well, which is titled as the creation of the method of a hip-hop display for cars using an iPhone. So could you please just again share the second presentation and go ahead? Thank you.
Can you see my screen?
Yeah, we can see it. Go ahead, please.
The second app also was created for iPhone. It's actually a head-up display for cars. For those persons who does not know what is a head-up display, nowadays it's quite often in many cars. So it is created a reflection of some data on the windscreen, and this way the user does not need to look down on the gauges. It can look on the windscreen, see the road, but also see some data which is important, some data from the car. Let's say the speed, what we are going, maybe some orientation, some GPS or some maps where to go, left or right, and something like this, some road signs and so on. So head-up display, or shortly HUD or HUD, it's a premium feature in these cars. And initially it was implemented in planes, but by the time the automotive industry evolved, they implemented also in cars too, because it's a really great feature. This is how the app looks like, a first print screen made on iPhone. So actually the app, I wanted to make it really simple. This is why I created a head-up display, because there are a few in the market, but from my point of view, there are too populated with a lot of useless information, like some sort of battery and lots of other signs, which is, from my point of view, it's useless. So I represented only the speed and the clock, the time. Of course, there is a way how to take this out too, and for my point of view, I wanted finally to make an app which represents only the speed of the car. As you can see, it is somehow upside down and it's mirrored because of the reflection. We need to display it this way to see it normally in the windscreen. So let's see, the hardest part of the app was to make this reversed view of the information. And I created also a digital display of the speed value of the car, and also analog gauge, which based on the speed, it will filled up more or less. The other part that I needed to be attentive to is to take out all of the other information from the phone. So no battery, no phone signal, no nothing, no other buttons, everything in a black screen, because this is the best way how it can be used to be reflected in the windscreen. And the information, which also the colors can be changed based on the LEDs in the car. I used orange because from my point of view, it was seen better. As you can see, some other print screens, so it's on different speeds, you can see some values, how it works, and then the normal pictures, how it can be seen in cars. I can tell you that at night it can be seen really well, but I wanted to put some pictures in the daylight to prove that it can be seen quite well in daylight too. And trust me, in this picture you cannot really see it. In real life, it can be seen really more clear and more accurate. So this is just the picture, but in real life it worked really well. And as you can see, if in daylight it can be seen like this, at night it can be seen really well. And the only thing that you need to acquire is this non-slipping mat, which it's €1 or £1, or it's a really low cost. So to put your phone, because otherwise it can be slip from your car. And as you can see, the app works quite well. Other print screen, I wanted to prove to you that even in the daylight, how well it can be seen in the windscreen. And there is no trick. You don't really need to do nothing. Just using this, it can be seen as a reflection in your car. And this is why you can see why it's best to have a black background, because you will see it really well in the reflection of the car. So this is the best solution. And to take out every other buttons, battery and everything, to see only the information that it's needed for you. As a conclusion, I would say, and I forgot to say it before, the speed is taken from the GPS of the mobile phone. So it's a really simple way to extract the speed value of this phone. We created this head-up display. It's good to use an app like this, because this way it can help drivers to respect legal speed limits. You see the speed limit in the windscreen of the car. Maybe you can it will help you to not get so many speeding tickets. Of course, the further enhancement would be to implement the app in Android system too. Finally, I would like to say that it was already implemented, but it's not the part of this paper. Again, redoing the app from scratch, different programming language and so on. Of course, it can be enhanced, this app too, by adding some other features like navigation and so on. But as I said, my idea was to keep it as simple as possible, because if we overcrowd again the image of the head-up display, again it will be worse. For my point of view, sometimes less is more. As acknowledgement, I would like to thank my university, Polytechnic University Timișoara, for the given support. These are some selected references, and I would like to thank you for your attention.
Thank you. We don't have questions on the chat box, but our chair for sure has his input and contribution.
Yes, thank you, ma'am. Roland, you have given a very good presentation. Technically, it's fine. But there is no type of architectures you have used, any block diagrams. Otherwise, how would we justify that? You are telling that, okay, the cost is so effective, but how effective it is throughout the system, if we can calculate what is the total cost of the system. And also there is, I suggest you to add a few block diagrams also, so that it can be helpful for us to judge the same. Thank you.
Okay.
Thank you. So I have a question which is raised during the discussion, which is it possible to add the speed limit of the specific road while the person is driving? For example, it can show, for example, that the maximum limit is 70 and you are currently 65. So just to consider that you may face a fine or something like this.
Yes, of course. So I said that is in the further enhancements. For that, it's needed to load some data from map data, and from the map data, there is also information for speed limits, also road sign recognition, and so on. So of course it can be
Yeah.
done.
Okay, okay. Then thank you for the presentation. The great efforts. It would really help everyone who's driving to use this application. As you've mentioned, with less headache, focusing on many details and take the most important information. So thank you for your contribution. And now we want to move to the
Thank
next
you.
presenter. Yeah, we want to move to next presenter with another great idea and. It's the time of Miss Irish, who would present a paper on behalf of the co-authors titled as Sentiment Analysis in Teaching Performance Rating Using Navi Bias Algorithm. So could you please just share your screen and unmute yourself? Yeah,
Yeah.
brilliant. Yeah, I will stop sharing it from my side. Share your screen and go ahead. We are all listening to you.
All right.
Yeah, we can see it. It's brilliant. Thank you.
Am I audible? Can you hear me?
Yeah, yeah, we can hear you and we can
All right.
see everything. Okay, thank you.
Yeah, all right. Thank you. Good day, everyone, and welcome to my presentation. By the way, please bear with me. I have intermittent internet connection here because it's been raining here in the Philippines in my location. All right. What I'd like to present to you today is our study entitled Sentiment Analysis in Teachers' Performance Rating using naive-Bayes algorithms. So again, let me introduce myself. I am Iris C. Wanatas, an associate professor and an IT coordinator from FEU Diliman, Quezon City, Philippines. I have divided my presentation into 6 main parts and structured as follows: the introduction, objectives, methodology, project design, results and discussion, and conclusion and recommendation. To start with, as Annette France puts it, you can transform something you don't understand. If you don't know and understand what the current state of the customer experience is, how can you possibly design the desired future state? And that the interest in sentiment analysis comes in because of its great number of applications. Sentiment analysis deals with computational methods in order to find, extract, and systematically analyze people's opinions towards certain topics. With the integration of sentiment analysis, it helps to identify and classify opinions expressed in text to determine the polarity, namely positive, negative, or neutral. Why naive-Bayes algorithm? It was highlighted in the study of CO 2015 that naive-Bayes algorithm is a flexible framework and with a reasonable performance is normally utilized for text classification. Many higher education institutions in the Philippines are gradually becoming more involved in quality measurements that offer evidence for decision making, policy direction, and funding requirements. As the most significant resources in an education system, teachers are critical to raise quality standards. The evaluation of teachers has been crucial in the field of education to provide comprehensive development program. It is considered an important role in teachers' professional development and it is necessity to have a close look at the teacher evaluation. Assessing teachers' performance in academic institution is needed mechanism to improve the quality of teaching. It is common observation in the Philippines that most of the current teacher evaluation systems look into quantitative measures gathered in the questionnaires. It normally relies on the fixed rubric rules and takes less into account the comments from the students. Teachers often have difficulty interpreting students' written comments on teaching evaluations. Although such comments are usually quite rich in observations and insights, teachers frequently struggle to draw conclusion from them. Rather, teachers remark the students' comments seem contradictory. Understandably, this can frustrate teachers and lead them to believe that there's no way to satisfy everyone. As a result, teachers may choose to ignore messages from written comments of the students. A well-designed, properly functioning teacher evaluation process provides a major communication between the schools and the teachers. However, most faculty evaluation systems are focused on quantitative or numerical ratings provided by the students. There are few papers also that use the qualitative or comments made by the students. So this study introduces an application with combined analysis of quantitative and qualitative responses using opinion mining techniques to provide comprehensive understanding of the teacher's performance. And the general objective of the study is to develop a teacher performance rating with the use of sentiment analysis using naive-Bayes algorithm that will evaluate teacher performance on both quantitative and qualitative results. Specifically, the study aims to design an application with gather ratings and comments, to create a database that will handle the gathered ratings and comments, to integrate a corpora of positive, negative, and neutral opinions, words, and connotations, and lastly, to evaluate the acceptability of the developed application using ISO 9126 metrics. The system architecture is presented in this figure. The system allows the student to provide quantitative ratings and qualitative ratings through the feedback in the form of comments and suggestions. The qualitative ratings will be analyzed using opinion mining with sentiment analysis engine. For data preparation, the comments or suggestion of the students will be extracted from the database. There are several procedures such as filtering, tokenization, and removal of unnecessary terms and symbols. The system uses corpora to identify the opinions expressed in a volume of comments or suggestions from students. Learning-based techniques is used to create a model by training the classifier with labeled examples. This means that you must gather a data set for positive, negative, and neutral classes, extract the features of or words from the examples, and then train the algorithm based on the examples. The dataset polarity of a list of dictionaries of words from the integrated corpora, which includes the Tagalog and the English words. Then the opinions extracted are analyzed to find out the polarity using naive-Bayes algorithm. Every sentiment word in the database has been given a value. When a sentiment word is detected in a sentence, the value saved in the database is used for evaluating the cumulative opinion value. And when a sentence is analyzed, for each sentiment word found in the sentence, its opinion value is fetched from the database. Then the collaborated opinion value of the sentence is estimated. So to determine the probability of a certain class, so if it is a negative or a positive class, their combined probability is obtained by multiplying the probabilities of each evidence. And to determine the final probabilities, the result must be summed to 1, whereas joint probabilities of sentiments is equal to positive, comma E, and probabilities of sentiments is equal to negative, comma E, where E denotes all the evidences given by the instances attribute values. Therefore, the higher the number of positive evidences, the higher the likelihood result of sentiments is positive. And the higher the number of negative evidences, the higher the likelihood the result of the sentiments is negative. A total of 100 respondents participated in the study. Purposive sampling was used to select respondents until the desired number of participants was reached. This used the mean performance to interpret the results based on the survey questionnaire. The developed system is an application to be used on the internet or local host and was written using PHP suited for web development and embedded in HTML. MySQL Server is used for database operations, including the storage and retrieval of login information. The application includes 4 major features, which includes Users Management Module, Teacher Evaluation Instrument Module, Student Evaluation Module, and Report Module. The Student Evaluation Module provides ratings and comments from the students, and comments are important in generation of sentiment analysis. The sentiment analysis using naive-based algorithm classifies the comments to positive, negative, or neutral category. An overall positive or negative or neutral evaluation of a teacher is given out from students' responses. The report module will create the final report of the teacher evaluation. The purpose of this report communicates the final rating which has been generated from the rating and comments of the students. And the result of sentiment analysis is combined in the final rating of the teacher as shown in this figure. This table presents the summary of weighted mean on the evaluator's response. The overall acceptability of the system based from experts' evaluation is 4.32 with an interpretation of acceptable. And for the conclusion, the evaluation was able to provide and handle ratings and comments in the performance of individual teachers to identify their strengths, potentials, and weaknesses. It was acceptable with 4.29 rating in terms of functionality as all the features and functionalities of the application were being developed. It was perfectly acceptable with 4.64 rating in terms of usability, which shows that the application is easy to use. It was acceptable with 4.02 ratings in terms of reliability, as the application provides the correct results. It was acceptable with 4.11 rating in terms of performance, which shows the ability of the application to provide results immediately and application speed to classify quantitative and qualitative results. And lastly, it was perfectly acceptable with 4.56 ratings in terms of security, which shows that the application is protected by security features and level of system access privileges. The overall indicator of the application was rated acceptable with 4.32 rating, which indicates that the application performed well in terms of giving importance on both quantitative and qualitative results. The qualitative rating analysis was measured and analyzed and complemented the quantitative rating analysis. The findings from the teacher evaluation system were used to provide feedback to teachers and guide their professional development. And for the recommendation, the researcher aims to use other natural language processing algorithms in creating sentiment analysis in future works. Researchers can add a grammar and spelling checker to validate the right and valid words for giving feedback in the future to further develop and improve the study. It also requires more data in the dataset, dictionary, as well as new corpora to improve classification analysis. Furthermore, additional algorithms such as multinomial naive Bayes may be integrated into the system to increase the percentage of accuracy in evaluating the system's performance when multiple occurrences of a word are present in text classification problems. And here are our references. And remember, be positive in your thoughts, be neutral in your judgment, and be negative to what is wrong. That's all for my presentation. Thank you for your attention.
Okay, thank you, thank you. We don't have questions till now in the chat box. However, if anyone wanted to raise anything based on the
Uh,
discussion with the chair, it's more welcome. So, our chair, what do you think about this great effort idea? Do you have
yes,
any?
yes.
Yeah,
Irish has
could you
done
please
a very
elaborate?
good work.
Yeah.
Am I audible, Irish?
Yes, yes, I
Yeah,
can
yeah,
hear you.
yeah. You have done a very good work. But
Thank
how
you.
you have judged the ratings like 4.21, 4.11, how it has been done? By the example of naive Bayes only or something else?
Uh, the evaluation here, the result of our evaluation, is conducted with our respondents. The 4.02, the 4.11, and the different result of the performance of our application.
Okay, what is the basic equation behind that?
Yeah, we only use the mean performance to evaluate the acceptance of the system.
Okay, and why you have used naive Bayes? Is there any other algorithms also over there which you may use, or only
Yeah,
naive Bayes only you have used?
we only use naive Bayes because, as I have mentioned, it is very good in terms of text classification, wherein we use the text classification in the comments and suggestions of the students in the evaluation system.
Okay, ma'am.
Yeah,
Fine, very good work. Thank you.
thank you.
Okay. Thank you for the effort to get the presentation. And now we will go ahead to the next. work, which would be presented by Mr. Pieper from University of Rostock from Germany. On behalf of the co-author, he will present a paper titled as using Ha- Hammond robot to assess post-stroke impairment with standardized neutralism therapy. Sorry, I'm really sorry for misspelling some of the words, but it's not my area. But for sure, after the presentation, all will be perfect with me. So please share your screen and go ahead with the presentation. We are all listening.
Okay, hi everybody. I hope you can hear me.
Yeah, we can
So
hear
as
you clearly and see the presentation. Go ahead.
it was already mentioned, so I want to report about our experience with humanoid robot Pepper, and we are working together with my colleagues in a project which is called eBrain, evidence-based robot assistance in neuro rehabilitation. That means we look at patients that suffer from a stroke. And sorry, how can I go to the next slide? No, now it works. So stroke is currently a very important disease everywhere in the world, but especially we have some data from United States from the year 2017. So every 40 seconds, someone had a stroke in the United States, and every 4 minutes someone died of stroke. So this is a bad news, but also good news. So not everybody dies, but even if you survive, sometimes you have problems with your arms, with your legs, or with your sides. So we came in contact with some people from medicine. They have therapies and ideas how you can cope with the problems. And the main idea is that you train parts of the brain that were not affected, and they help you to recover. So they take over more or less the part of the handicapped area of the brain. And there are different therapies. The first one is arm-based training. That means that the patient really needs help to move the arms. So you see one figure there. There are exercises to move the arm, and somebody helps. If you are a little bit better with your arms, then we have the arm ability training. There are specific training tasks. You have to find some points on a sheet of paper. You have to follow a labyrinth, or you have to move objects. And then there's another therapy, neglect training. So if you miss some objects, you train to identify objects that are different to other objects, or objects move and you have to follow them. And the problem with all these training tasks is like with a fitness club. You have to do a lot of training sessions until you see some good results. So this is the same problem has the patient. So it's a lot of training is necessary. So you do not see success after 5 exercises. So you need a lot of therapists to support the patients. And there was the idea of our colleagues from the medicine department that maybe a humanoid robot can help for this problem. So it's not our idea that the robot takes over the whole task of a therapist, but after the introduction of the exercises and the first session of exercises with a human, a robot might observe the next sessions of training. So from the second to the 20th repetition of exercises, the robot might help to motivate the patient. That's the main idea. He can also give, or the robot can also give hints how to perform several tasks. It presents videos on his tablet, and you see a picture of this Pepper. It looks very cute, and if people look at this guy, then they have to laugh. So it's really a nice guy, and we hope that this guy can motivate people in the right way during the training tasks, and to continue and to also recognize when they are tired and then suggest a break and do something else. So we are looking whether this works with patients. Unfortunately, we only developed the application until now, and it was not possible to perform real evaluation with patients because of COVID. Here you see some examples. The robot has a lot of sensors, but it's difficult to really observe whether people were able to hit a point on a sheet of paper or follow a labyrinth on paper or following the cross out of these different O's on a sheet of paper. Therefore, we had to digitalize these tasks. So our idea was to use tablets for this purpose. On the left-hand side, you see how the one task looks like. Then on the tablet, of course, we can give the information to the robot that the circle was hit or whether the connection between different circles was correct. On the right-hand side, you see a video where a student performs the exercise where you have to cross out the different O's. If the crossing out was okay, then you see the green background. If there was a mistake, then the background becomes red and you have to repeat to cross out this symbol. And here you see on the robot, we present the results of the last training task. So to motivate the patient, oh yeah, you improved a lot. And now we have to study in the future. If they do not improve, what do we show? Maybe we don't show the diagram if the result become worse, but motivate in some way. Though it's maybe the robot can say, yeah, we have a little bit drawback now, but it's every patient has the same problems. After 1 week, you have to start again and to have more engagement, and then we will make it soon. Okay, if you look at the website of the company that sells Pepper, then there are tutorials how to program the robot. And we recognize, okay, this is possible, everything is possible to program on the robot. And our first application was programmed on the machine there. But after a while, we recognized, okay, the software becomes quite complex, and it would be good to have different tools for this purpose to visualize the interaction of the robot with the patient. And therefore, we implemented an own interpreter for a state machine. And this is interpreted on the interaction server. So we have a specific Python's implementation of this state machine. And these dialog scripts are loaded on the server. And then we have a communication with a MQTT server, a specific technology. There might be other techniques possible as well, but MQTT doesn't need a lot of resources. And in this way, we can communicate with messages to different systems. For instance, at the beginning, we tried to use the tablet of the robot, but this is not very convenient for patients. So it's better to have a tablet on the table and draw on this tablet. So with this structure, with this MQTT server, we can integrate 2 tablets, a touchscreen for our neglect therapy, and we have a flickboard. The robot understands natural language. However, stroke patients have often problems to pronounce correctly. If this is the case, we use the flickboard to substitute yes. If the patient puts a hand on the flickboard, that means yes, I'm ready to continue. So he does not need to pronounce it correctly. The flickboard helps in the situation. We also recognize that we need a management of our therapies, and we introduced or we programmed administration tool. This is web-based, and the therapist can enter user data and the plans for the exercises. How often does he have to perform certain exercises, and also the schedule on which date at which time will there be a session. and all data are stored there in a user model. At the beginning, some data from the interviews with the patients, and later we store all the exercise data on this in a user model, in the user model database. We are currently developing a domain-specific language. This means the language is more appropriate for human reading, and there we develop a tool that generates our dialogue scripts, so it's more appropriate for the programmer. And we already have a visualization tool that presents our scripts as a graphical display, and in this way you can recognize whether some connections are missing, you have some deadlocks in your state machine, or you have cycles where you don't want to have cycles. So this is a kind of support for our programmers. So the discussion might be whether it's good to have a fat robot, or we call it like with clients, fat clients and thin clients. So we call it fat robot. If everything is programmed on the robot itself, this has advantages, of course. It's simple to access the feature of the hardware of the robot, and you can sometimes use components that were already programmed by the company, and this, of course, can be smooth integrated in your application. But like with other machines, if you have a lot of sensors and equipment in your hardware, it is often not the best one. So there are already new sensors too, and we need better cameras, for instance, and you want to integrate external tools. In this way, our architecture helps us to integrate services we want. So a totally thin robot would be that it only talks. We have one application where the robot does nothing else than talking the text that is sent by messages to the robot. So it doesn't know any state or something. Everything is on the server. However, sometimes it might be good to have a mixture of both. So for instance, we want to detect the emotions of the patient. And Pepper provides quite a good software that is based on images and voice. So there are other tools as well, which only look at the faces and try to identify the emotion. But the Pepper software also looks at how the tone of the voice is currently, and combines both. And this way, it might be good to have this software on the robot, but all the other software outside. So it's a mixture, not the totally thin robot, but a mixture of both fat and robot.
Okay,
So
for
we have provided some videos.
2 minutes.
Yeah, I'm finished. Some
Okay,
videos for if you are interested, you can look at the videos with what the robot says. And I have to acknowledge our fund giving institutions, and I'm finishing now. Thank you very much for your attention.
Thank you for the great idea. It would be helpful to everyone who suffered from this illness. So thank you for the efforts and for saving the humanity. We don't have questions on the chat box, but our chair for sure has a great input and some questions. They would not be difficult for you.
Professor Peter, thank you. You have a great work by using a humanized robot. But what type of training method actually you have taken care of? What type of training actually you have done here?
Sorry, I didn't quite understand. What type of what?
Training.
Okay, so all these training tasks. So you have to cross out these I didn't tell it in. You have to. The arm is not allowed to put on the table, and you have to cross out the O's, as many as you can in 1 minute. So, and the patient has to do this, let's say, every day 5 times.
Okay,
so, and it's
okay.
quite boring to observe. And we identified that even a human cannot recognize this. Even if you cross out an O, it's very difficult if you sit next to the patient and look all the time on the sheet of paper. But with our tablet application, we can exactly say, yes, that was a good cross. So for instance, we do not allow that you have a circle inside the O. That's not allowed. It has to be a line. And the entry point and the exit point have to have a certain distance. You cannot have only a shortcut, something like that.
Fine,
And
fine,
that's
fine.
the idea. And the robot is motivating. So, but we have to learn a lot as well with our patients. And it might also depend on the character of the person, whether you talk a lot with them or you interrupt them only a few times.
Great. Nice presentation. Thank you.
Yeah, I like the project.
Yes.
I developed software for a long time, and often you have the problem that the people lose their jobs with your application. But here it's really supportive for patients.
Thank you. Nice. Over to
Thank you.
Fairuz, ma'am. Thank you.
Thank you. Thank you for the presentation and for the support as well. So now we want to move to another presentation presented by Mr. Badr from Oman Tourism College in Oman on behalf of the co-author, sorry, he would present a paper titled as Situational Analysis of Remote Learning Using Logistic Regression and the decision trees amid this COVID-19 pandemic. So we are all listening to you, Mr. Badr. Could you please just share your screen?
Yes, sure. Thank you very much.
Thank you.
And just
Yeah, to make it easy, it's
sure.
there is a green button on the bottom part of the screen behind the chat. Just press it and select your screen.
Sure.
Yeah, brilliant. We can see it now. Okay.
Thank you very much. And I don't know if it's morning or afternoon with you there, but here we have afternoon. It's already 1:30 in the noon time. This is better. And thank you very much for this host. I just want to start with the paper that we have developed earlier regarding the academic side on how students and faculty members cope with the pandemic in the last 16 months. And as you know that most of the institutions, they switched from in-person attendance to the online. And of course, throughout this pandemic, we have experienced so many obstacles, especially with those students or even faculty members who are not that much familiar with the technology or even what we call it the distance learning. So we started to think about conducting a research or a paper about how we can get better understanding of online learning over here. I mean, in the Middle East part, especially in the Sultanate of Oman. Of course, as an overview of this research that we, amidst the continuous of upsurging COVID-19 pandemic worldwide, there are still postponed and of course continuously implementing remote learning. And based on the previous experience, there are still significant number of let's say students and teachers facing similar challenges with the online mode. Four most important parameters that we thought about namely availability of IT resources, bandwidth, IT skills proficiency, institutional subsidiary, and of course we consider some other issues in that aspect. Also, we have given a questionnaire to approximately 420 faculty members and students in the college to participate in this survey. And of course, we tried to maximize the outcomes of this research to get a better idea and even to get more and broader knowledge about how this obstacle or this issue can be resolved. The logistics regression and of course decision tree are used to analyze the parameter situation where the remote learning is employed. As a result of that, we found a number of results as well. Just where which has a confidence level of approximately 96%, whereas these give a very good indicator of how we predict the IT skills, proficiency, internet bandwidth, and of course the significance parameter that improve needs to be improved during the pandemic. Decision tree or binary tree. Decision tree or binary tree is used in this study to determine the predictors that mostly affects the state of the respondents in terms of dealing with the online mode. The logistic regression also used in this study to evaluate the correlation between the predictors and the accuracy mathematical expression that will predict the reliability on how we get better understanding that these challenges, where are they and how we can overtake these challenges. The method of the research that we have focused on, as I said, we have given a survey to 420 faculty members as well as students. And of course, we designed the logistics regression, classify whether the respondents are high achiever or low achiever. I mean, in which extent that they make achievements or they get the maximum use of the technology or the online learning, or lower achievements. So we classified them based on these two levels. The design decision tree, we made also a design on how we prioritize based on respondents' prioritizations, and determine which parameters are the most significant to the respondents, which are the tools that or the equipment that they need to get better achievement and better use of the technology. Of course, the phases that we conducted the achievement of these objectives, we distributed the survey for confidence level. The survey was conducted for, as I said, 420 respondents from the college, Oman Tourism College. The 4 parameters on the survey, the level of availability of IT resources, which extent that the students or the respondents, they have an access to these IT resources. Of course, the proficiency, in which extent also they are able to deal with the technology, internet speed and bandwidth, and of course the institutional subsidy funds data are used to analyze the confidence level of respondents, which are related to the individual conditions. And honestly, based on what we have seen, this is a common issue, not only in this part of the region, and I think it's worldwide issue as we have selected these 4 parameters. We have also designed the logistic regression classifiers. The logistic regression is used to analyze the correlation between the 4 predictors, a mathematical equation none as the classifier function is driven to predict a good response from the given predictors that will determine whether the respondents are classified as a high achiever or low achiever, which means that these respondents may need additional attention or support to fully survive in full online remote learnings. And as I said, we try to make sure in which extent that students or respondents use these four parameters, and in which extent that they they use it as maximum or minimum there. We received a good also respondents from those who were given these surveys. And of course, the four predictor used as the output of the model conditioned by the method to come up with the respondents or the response. The decision tree chart generated to show a clearer understanding to the contribution of the predictors underlying the level of confidence into the respondents. And as you can see here, the four parameters goes with the decision tree or binary tree and gives the analysis of the predictors. As a result, the logistic regression in the first table, we have implemented the questionnaire or the survey for all of the students. And of course, we received approximately 249, we have done 249, 94 response or surveys. Out of this service, we received different thoughts from these students as well as the faculty members. The accuracy, and it's worth to mention here that the accuracy were 96%. Out of these figures, we received different, let's say, values, and the value that shows the regression classifiers. Those values give us a good indicator on how students and faculty members needs, in higher level of, let's say, training, as well as they need subsidiaries in this study as a priority of using the online, or even maximize the using of the online needs. In addition to that, we have get another results of from the respondents in terms of higher achiever and lower achiever from the threshold of 0.5 chosen, and of course below the 0.5, where it gives the higher than 0.5, which means that it's a higher achiever. Below them, it's the other way around. The above 0.5, it's lower achiever, and below 0.5 is higher achiever of the IT technology. The show confusion of metrics in this figure. It shows different also test stage of logistics in terms of respondents that classify the achievers who may need extra attention support, while one represents that they need more classifier or even more classified higher achievers, where most of them showed that they need a better support and to get higher achieving in terms of full online learning there. A summary of the results of the test stage on logistics regression in terms of low achiever to higher achiever classified correctly. 36 mentioned that it's a lower achiever, and of course the classified incorrect 3 and lower achiever. Higher achiever classified correctly 85 respondents, and classified incorrectly 2 achievers. In total, 121 compared in terms of correctly classified, compared to 5 classified incorrectly. The decision tree. The predictors and the variables.
Sorry for interruption, but we have 2 minutes more.
Sure. Variable predictors and respondents with the remarks, in which extent that we need to get this breakdown of counts used in the implementation of logistics regression in MATLAB. 294 responses are used in the training stage, and 126 responses to use in test or testing stage. During the testing stage, the logistics regression achieved an accuracy of 96%. In addition to that, in decision tree, 7 shows the branches of decision tree are binary tree classifier. It shows what predictor greatly affects the classification of the respondent, and it is seen that in internet speed, bandwidth x2 is the most significant parameter in the classification problem, followed by the level of IT skills proficiency of the respondents. In conclusion, 420 respondents participated in the survey to analyze the current status with the full online mode. Logistic regression 4 parameters were used. The respondents of logistic regression is whether the respondents of higher achiever or lower achievers, and show the requirements in online mode. 70% of data set is used to train logistic regression model, and 30% is used to reliability of model, which classifier the function is driven by the availability to classify with the respondents. Decision tree or binary tree illustrates which among the 4 parameters or predictors significantly affect the situation of the respondent from the branches of the decision tree, and the internet speed, bandwidth are the most significant parameter. In addition to that, the proficiency of the IT skills.
Okay,
From the 2 classification method online.
Yeah, sorry, less than half a minute. I'm really sorry, but we have reached that time limitation. I'm sorry.
The decision tree, however, shows which parameter needs more attention and improvement. The level of institution and subsidiary fund may be at least significant parameter, but also affects the level of availability of IT resources to each respondent. The higher the support in the institution offers, the better IT resources and internet subscription the respondent may acquire, which results to become in higher achiever. This is in general, in brief. We have so many details to go in, but unfortunately the time is very limited. Sorry for being taking all of this time.
No, thank you, thank you. It was brilliant, and thanks for the great efforts. Professor, what do you think? What's your input on this presentation and the idea?
Yes, he has presented a very good point actually. In already have given situational analysis of remote learning using logistic regression and decision trees very well. I just want to know that you have given 70% and 30% in testing, training and testing. Have you
Mhm.
tested 60-40 or 50-50 or like 65-35 or like that?
Unfortunately, no. Why? Because we were not able to get a direct access for both, because we mix between the students as well as the faculty members. And as what we recommend in the future, we have to separate a little bit, where we give students a separate, let's say, survey from the faculty members of the institution, to get the figures that you mentioned, or you just mentioned, to get also more accuracy on the side of what we are looking for in terms of challenges of full online or remote learning.
Yes, yes, that's why I pointed out that point. Very good
Mm.
presentation at last you have done. Thank you from
Good.
my side.
Thank you very
Thank
much.
you.
Okay. Thank you. Okay, so now unfortunately our last presenter is not here for this paper, and accordingly I wanted to close the session for today. So I sincerely thank you, our authors, for the excellent presentation and contribution in the session. All of your presentations were great, and it's really contributes to the knowledge and to the humanity with great implications and reflections. We hope that the session was informative enough. All of you, our dear presenters, will get your online or digital certification within a couple of business days. But please keep an eye on your emails if our team wants anything to make the progress as expected. Also, all papers have been already communicated with the Springer to get publication. As usual, it takes time, so it's approximately 5 to 6 months. But we hope by your cooperation with our team again would be faster and as expected. I thank our chair for the input, the contribution, and for chairing this session. Your questions and notes were really relevant and supportive to the researchers. So thank you, and please accept the appreciation of our team as Words is for and as a Global Knowledge Research Foundation. Thank you, sir, for the great contribution again, and we hope to see you and all participants next year with physical presentation. Enough is enough with online and Zoom. However, we still have a chance to make memories and have a picture. So could you please just turn on your cameras where we can take a picture for memory? Yeah. And in the classical way, I will count down and say cheers. Okay. So 3, 2, 1. Thank you, everyone. Please stay safe, take care of yourselves, and hopefully again see you soon next year with the physical presentations, and hopefully everything would be okay with everyone. Take care, and we hope also to see you with our next session. It will be approximately 1 hour from now. It would be a little bit less, but it's by 11:40. So see you there in the next session, and thank you again for your time. Bye bye.
Thank you very much.
Bye bye.
Thank
Thank
you,
you.
ma'am. Thank you,
Bye.
sir. Bye.